You know, all those apps on your phone, the games you play, all that software you use every day? Have you ever just stopped and wondered what's actually making it all work? It really can feel like a bit of magic, right? Well, let's pull back the curtain on that. See, underneath all that magic, when you really get down to it, all software is built on some surprisingly simple, really elegant ideas. And today, we're going to dive deep into one of the most fundamental of them all, the programming variable. So here's the game plan. We'll kick things off with software's secret ingredient. Then we'll talk about what a variable actually is. Think of it as a container. We'll cover the rules for making them, what you can put inside, and then we'll meet their unchangeable cousins, constants. And finally, we'll tie it all together and see why this stuff is so important. Okay, so to really get where variables fit in, we first need to ask a bigger question. How does a program keep track of, well, anything? It all starts with a concept called an identifier. Think of identifiers as just labels, plain and simple. They're names you give to all the different pieces of your program. So instead of the program having to think about that number over there, you can just call it score or player health. It makes everything so much easier to find and manage. And for us today, the most important kind of identifier is, you guessed it, the variable. All right, and that brings us to the main event. What in the world is a variable? Let's get the official, kind of textbook definition out of the way first, just to set the stage. Okay, so it's a symbol whose value can change. Simple enough. But honestly, that's a little dry. I think this next way of looking at it makes it click so much better. A rough workspace. I just love that phrasing. It's kind of perfect, right? It's like having a little scrap of paper next to you when you're working on a hard math problem. You can just jot down a number you'll need in a second, use it, and then erase it for the next step. It's a temporary holding spot. And that idea of a workspace leads us right to the classic analogy, the one everyone uses because it works so well. Think of a variable as a labeled box. That's it. You give the box a name, you put some information inside it, and here's the key part. You can come back later, take that info out, and put something totally new in its place. This incredibly simple idea of a container with changing contents is what makes software feel alive. Okay, so we've got this labeled box idea down, but how do we actually, make one in our code? Well, it's a pretty straightforward two-step dance: declaration and assignment. So step one is declaration. This is you telling the program, hey, I need a new box. It's going to be for whole numbers, and I want to label it score. Boom, the box exists. Then comes step two, assignment. That's when you actually put something in the box, like saying, okay, put the number 100 inside that score box. Now, of course, you can't just name these boxes whatever you feel like. There are some ground rules. In a language like Java, a variable name has to start with a letter, an underscore, or a $sign. After that, you can use numbers, but you can't start with a number. And you definitely can't use weird special characters or words that the language already uses for its own commands, like int or class. And this one is a really big deal. Just imagine the chaos if you had two kids named Sarah in the same class, and the teacher just yelled, "Sarah!" You wouldn't know who they were talking to. It's the same in programming. You can't have two variables with the exact same name in the same part of your code. The computer would have no idea which box you wanted it to use. All right, so we know how to make the box and how to label it, but what about the stuff we put inside? Well, the type of box you make actually determines what it's allowed to hold. And in programming, we call this its data type. And the data type is so important. It tells the computer two things: what kind of information the variable can store and what you can do with it. For instance, an int box is for whole numbers, a double is for numbers with decimal points, a Boolean box can only hold one of two things, true or false, and a string is for text. See, the type is what lets the computer know that you can add two ints together, but you can't, say, multiply two strings. Okay, now this slide is so important because it clears up something that confuses a lot of people, that equals sign. In math class, x equals x plus 5 is a statement of fact that just doesn't make any sense. But in programming, it's not a statement of fact, it's a command. It's an action. It means go find the box called x, look at the number inside, add 5 to it, and then, and this is the key, put that new total back into the box x, replacing whatever was there before. And by the way, that little piece of the command that does the math, the x plus 5 part, or something like height times width, that has a name. It's called an expression. It's any bit of code that the computer can calculate down into a single result. So far, we've talked all about how variables are built to change. That's their whole thing. But what about values that should never change? Things like the value of pi or the number of hours in a day. For those, we have a special tool called a constant. A constant is pretty much just a variable with a force field around it. Once you give it a value, that value is locked in. It's set in stone. In a language like Java, you just put the word final in front of it. This does two great things. It signals to anyone reading your code that this value is fixed, and it physically stops the computer from letting you or anyone else accidentally change it later on. It's a fantastic way to prevent bugs. So let's just put them side by side to make it super clear. A normal variable, like score, gives you flexibility. Its whole purpose is to be able to change. A constant, like days underscore in a week, gives you stability and safety. Its value is locked. You absolutely need both of these in your toolkit to write good, clean code. Okay, time to zoom back out and put all these pieces together. We've gone through the what and the how, but let's really hammer home the why. This is where you see the big picture. So if you boil it all down, it's this. Variables are our named containers for information. Simple as that. We create them by giving them a name and a type. That type tells us what can go inside the container. We use the equal sign not as a question, but as a command to put something in the container. And if we want to make sure the contents never ever change, we just lock it up with the final keyword and turn it into a constant. And this right here brings us full circle back to where we started. That so-called magic in your favorite apps, it's not magic at all. When your browser remembers all your open tabs, or a game keeps track of your score and your ammo, it's all just the incredibly clever management of millions of these simple little boxes being created, read from, and updated over and over again, thousands of times a second. So I'll leave you with this to chew on. Just try for a second to imagine writing a program without variables, without any way to store a piece of information and change it later. How would a game remember your score? How would an app remember who you are? How could anything at all adapt or react from one moment to the next? It couldn't. And that's why this simple little concept of a labeled box is truly the secret engine that drives all software.